Hi there, Mr. Holcomb here with another episode of The Math Behind the Modules. Lesson 19, Equations for Tangent Lines to Circles. Okay, classwork opening exercise says a circle of radius 5. So there's our key right there. Circle of radius 5. R equals 5. Passing through this point, what is the special name for that segment, AB? Well, we need to find out how long AB is. If it is of a length of 10, we would know it's a diameter. If it's more than 10, we know it's a secant. If it's less than 10, it's a chord, okay? So I'll explain that in a minute, but let's just find the distance between A and B. So we'd say the distance equals the square root of x sub 2, 3, minus x sub 1, minus a negative 3 is plus 3 squared, plus y sub 2, 1, minus y sub 1, 3 squared. So the distance equals the square root of 9 squared plus negative 2 squared is 4. Okay, actually, let me just show that since I showed the 9. Let's just say negative 2 squared. That is going to become the square root of 81 plus 4. So the distance is the square root of 85. Well, the square root of 81 equals 9, and the square root of 100 equals 10. So 85 is approximately 9 point something. So I'll go check that, and the square root of 85 is 9.219. Okay, so if the radius is 5, the diameter equals 10, and this is less than the diameter. So what that means is if I have a circle and I have a radius of 5, then the diameter is 10. And since this is 9.219, it is shorter than 10. So it would have to be, let me just draw the diameter instead of just the radius. Let me put a dot at the center. So I'm going to extend this out. So that's going to be a diameter. So if that is 5, this is 5, the whole thing is 10. Well, if I have a segment that's shorter than that 10, then it can't be as long as the diameter. So it'd have to be shorter. And as you go away, they get shorter and shorter. As you can see that this chord here is shorter than this chord. As you get closer to the center, they get longer. The longest chord in a circle is the diameter, which is 10. So since this is less than 10, it is a chord. Okay. Okay, so I brought a graph in just to explain this. It says how many circles can be drawn that meet the given criteria. Explain how you know. Well, the given criteria is a circle with radius 5, and it's going through a point negative 3, 3, and 3, 1. So if I put a point at negative 3, 3, that is right here, and 3, 1 is right here. So now if I draw a circle centered at the origin, just to get my radius straight, the radius of 5 would be right there. So let me make this thinner. And let's make it blue or red or something. Okay, so there's my circle. Okay. Well, if it is going to touch this point and this point, okay, let me draw a radius to that, by the way. So let me put a center. So here's the center of the circle. And then if I draw a radius, let's just go from negative 5 to 5 right here. Okay, I'm going to put these together. So if we have a circle, here's my circle. Where can I move that? So, well, I could have it here. See how those 2 points touch up there? So if I connected a segment and showed what that chord is from the problem number 1, let's do it in green. Then the segment that we were talking about from here, -3, 3 to 3, 1 is right there. There is our chord in the circle. Well, where else can this circle? So there's one circle. So if I copy it and move it somewhere else, can I move it somewhere else? Well, I could move it down here so that the circle touches at 2 places right there. So there it is. And that is the answer to this problem. Only these 2 circles. Let's get this out of the way now. Okay, there's one circle, there's another circle, sharing those 2 distinct points with that chord. So the chord could be in the circle down here, or it could be in the circle up here. So how many circles? The answer is 2. And that is the explanation. All right, so what is the slope of segment AB? Well, A was -3, 3, and B is over here. So I want to know what the slope of that line is. And so we say M equals y2 minus y1 divided by x2 minus x1. And that is going to equal 1 minus 3 over 3 minus a -3, which is 3 plus 3, which is going to give me a -2, 6, which is a -1/3. So down 1 over 3, down 1 over 3, as you can see in the graph. The midpoint of AB, midpoint equals y1 plus y2. I'm sorry, let's do the x's first, ordered pair. It is going to be a point, comma, a point, x comma y, and it's going to be x1 plus x2 divided by 2, and y1 plus y2 divided by 2, and that is going to give us the x's added is 0. 0 divided by 2 is 0. The y's added are 3 plus 1, which is 4. 4 divided by 2 is 2. So 0, 2 is right there, and sure enough, that is the midpoint. E says find the equation of the line containing the diameter of the given circle perpendicular to AB. So what they're asking for in this situation is here's AB. Here's the diameter down here, or here's the diameter up here. Okay, but we would have to rotate these circles that I drew so that the diameter is parallel. So let me rotate that circle like that, and let me rotate this circle. Oops. All right, that didn't work because I didn't pair them. All right, so in other words, if this was the diameter like so, so I just rotated those 2 circles so that the diameter is parallel to AB, and we want to find the line that contains the diameter of the given circle perpendicular to A. So what we're looking for is the equation of this line that goes through AB at the midpoint and is perpendicular. So it'd be something like this, just to give you an idea of what we're looking for. So I want to find the equation of that orange line. This isn't quite perpendicular. Maybe more so like that. Okay, but hopefully you get the idea. So we have this diameter and this diameter are parallel to that segment AB that was given in A, and they want us to find the equation of the line containing a diameter of the given circle perpendicular to AB. Okay, so containing the diameter, I guess they would mean this way, like that. So let me change that thought. They don't have to be parallel. The diameters need to be perpendicular. So there's our 2 possible choices. And so therefore the diameter is the same line. So I want to find the equation of that line that is perpendicular right here. Okay, there we go. So the slope of a perpendicular, for starters, is the negative reciprocal of the slope of the original line segment. So if it's negative 1/3, it's going to be positive 3/1 or just simply 3. So we have the slope of 3, and we know the midpoint, and we know two endpoints. And it says, find the equation of the line containing a diameter of the given circle perpendicular to AB. So I want to go through the midpoint, which is the point 0, 2. So now I have a point 0, 2. So when you have a slope and a point, you use the point slope formula. Y minus y1 equals the slope times the quantity x minus x sub 1. So it's going to be y minus my y, which is 2, equals my slope, which is 3, times x minus x sub 1, which is 0. So I'm going to get y minus 2 equals, and x minus 0 is just x, and 3 times x is 3x. So then when I add 2 to the other side, I'm going to get y equals 3x plus 2. So this is a slope of 3, 1, 2, 3 over 1, and it's crossing at the y-intercept of 2. So the equation of the line perpendicular to AB that is on the diameter is y equals 3x plus 2. And F says, is there more than one answer possible in part E? Well, no, because if I move these circles, they can't be on the endpoints unless they're talking about the diameter just being anywhere. So if I moved the diameter or moved a circle such as this one, if I move the circle like over to here, okay, I could use the endpoint here, I could use the endpoint here, or any other point. So is that what they're asking? So that would be a no. I don't think they were looking for that. They want the line containing the diameter of the given circle perpendicular to AB. So if I move this circle like I just showed you over here, then like here, then this point down here, A is no longer on that circle. So there is only one solution. So is there more than one solution? And the answer is no. And if you want a narrative on that, or so we could say, although two circles may be drawn that meet that given criteria, the diameters of both lie on the line perpendicular to AB. That line is the perpendicular bisector of AB. So we want to be over here so that our two endpoints AB are on either one of those two circles and it's the same diameter. So there is only one solution. Okay, page 2, example 1. Consider the circle with the equation x minus 3 squared plus y minus 5 squared equals 20. Find the equations of the two tangent lines in the circle that each has a slope of -1/2. Okay, this is a pretty challenging example, but just please try to follow along and stick with me, show some grit, and hopefully you'll understand at the end what just happened. So for starters, what do we know? Always don't try to look at the whole picture and say that's too much. Just look at little pieces, okay? And so looking at this equation, I know that the center is 3, 5. So with that being said, I can just simply come down here, go over 3, up 5, and there's my center, okay? Fairly simple. The problem here, though, is our radius equals the square root of 20, because this is r squared, so this r is the square root of 20. Square root of 20 is an irrational number. It's not a perfect square. Square root of 25 is 5. Square root of 16 is 4. So this is 4 point something, and it's less than 4.5 because it's closer to 16 than it is to 25. Anyway, it's irrational. I can't find an exact value. It says to find the equation of two tangent lines to the circle that each has a slope of -1/2. So given a grid, you can't do this on paper, but I can do this with the program, but you get the idea. If I'm going to be doing this, I'm going to draw a line. I'm going to start it here, and the slope is down 1 over 2, down 1 over 2, down 1 over 2. You get the idea, 1 over 2, down 1 over 2. This is a line with a slope of -2. Let me put it right on the corner so it's more accurate. Okay, there is a line with a slope of -1/2. I want two of them. So I'm just going to make a copy now. And I'm just going to set these off to the side for now. And I'm going to explain what I'm going to do. If I take a compass, I can't draw a circle because I don't know what radius of square root 20 is. So if I get my calculator out and do the square root of 20, I get just under 4.5, 4.47. So I could do an approximation of a circle with my compass, and let's do it in purple. And if I put my stylus point at the center here, use this and use my arrow keys to get it right there. And then I'm going to open it. Well, what did we say it was? It was 4.47, almost 4.5. So I'm just going to do this. Do not do this. This is a radius of 2. Radius of 3 would be out to 6. 2 to 6, that would be actually a radius of 4, or 3 out to 6. So my center was, let me make sure, 3.5. Yes, 3.5. And this is a radius of 1, radius of 2, radius of 3, radius of 4, radius of 5. We want 4.5 or just shy of 4.5. So it's somewhere around here. So this is what my circle will look like. Don't draw the circle yet because of what I just recently said. But there's our circle, approximately. Could be a little bit bigger around, or it could be a little smaller. Okay, so what we want to do is we want to, what do we know about this? Well, if I have one of these lines now that are tangent to the circle, that means they're going to touch the circle at one point on here. Well, what do we know about the point of tangent C? Well, that's going to be a perpendicular to our radius. So if I draw a radius from the center up to my point of tangency, which is somewhere around there, I am forming a right angle. That is what point of tangency means. So that tells me that if this is a slope right here of -1/2, I now know that the slope of a perpendicular is its negative reciprocal. So the slope of my radius is 2. So with all the things that we know from prior lessons, we can use this to solve this problem. So let me just put that there. So there is now a diameter, and that means that we have another tangent over here at this point. Let me just get it so that it's down here looking like a tangent right there. And that is going to create another right angle right there. Okay, so what are we trying to find? Well, it says find the equations of these two lines of tangency, these two red lines. Okay, so we already know that the equation is going to be y equals -1/2 x, but I don't know my y-intercept at either point, and we can't estimate. That's not 1.7, it might be 1.75, it might be 1.8. We don't want to guess, so we need to figure out how to do this. Okay, well, we're given a point. This is the point 3, 5. And if I call this point right here, let's call it A, and I'm going to call that x, y, then I'm going to do the slope formula. So over off to the side here, let me get rid of this, by the way, move that out of the way. So I'm going to write m equals, well, what is the slope? It's y2 minus y1 divided by x2 minus x1. I know my slope is 2, so I'm going to substitute in what I know, 2. I can call, let's call this my 1 and this my point 2. So I'm going to say y2 minus y1 divided by x2 minus x1 right here. So now I have an equation with 2 unknowns. So there's not much more I can do with that at this moment. But what I can do is get x minus 3, I can move that over. So multiply both sides by x minus 3 will give me 2 times x minus 3 equals y minus 5. Okay? And let me put these in parentheses because we're trying to see what's going on here. We have an x minus 3, we have a y minus 5 there. And so we're leading up to an equation with the circle, and we're trying to find a linear equation now. So now let's focus on this equation right here. And now I'm going to write that and use that one. So I'm going to write x minus 3 quantity squared plus y minus 5 quantity squared equals 20. Okay, so I'm going to use my circle equation and this equation that we got from our information from the slope equation. All right. So then I'm going to say, well, if x minus 3 squared is y minus 5, I can substitute y minus 5 in for my y minus 5 here and get it all in terms of x. So when I do that, I get x minus 3 quantity squared plus this squared, y minus 5 squared. I want this to replace y minus 5 because y minus 5 equals 2 times x minus 3. So I'm going to put that in here and I'm going to square it. I'm going to show it first. 2x minus 3 squared. So I'd replace my y minus 5 with 2 times x minus 3 because they're equal from here. And that's still equal to 20. Okay, hopefully you follow that. Simple substitution. And now I'm going to simplify it a little further. X minus 3 squared plus, now I'm going to distribute. 2 squared is 4, and then I get this x minus 3 squared. So all I did was distribute the 2 here and here. And that's still equal to 20. Okay, so x minus 3 squared plus 4x minus 3 squared is... Okay, at this point, there's two things I could do. I could distribute again and say it's x minus 3 squared times 1 plus 4. But instead of that, I'm just going to say, well, x minus 3 squared, there's one of them. 1x minus 3 squared plus 4x minus 3 squared would equal 5x minus 3 squared. I hope that's less confusing than distributing or factoring. Okay, so then I'm going to divide both sides by 5, and I get x minus 3 squared equals 4. Okay, so therefore, I'm going to now take the square root of both sides. Okay, I'm trying to solve for x, remember. So if I take the square root of both sides, I'm going to get two equations. I'm going to get x minus 3 equals, the square root of x minus 3 squared is x minus 3, and it equals 2, or I can get what's under the radical, x minus 3, and it's equal to the negative square root of 4 is also negative 2. Negative 2 times negative 2 is also 4. Solving for that, I get x equals 5, or I get x equals, adding 3 to both sides, I get x equal to 1. So x can equal 5, or x can equal 1. What that is telling me is my point of tangency is at the point 1 comma something, which is right here, and it's at the point 5 comma something right there. So I am off just a little bit with my points, so let me just move those. So I'm going to move this so it's right on the line 5. And again, my circle might not be the right rotation, right? Or the right size. So if I now move this to 1, it's going to end up like right there. So I will look at that in a moment, but we might have to adjust. Let me just move this since I moved the line. Okay, so there's the point 1 comma something and the point 5 comma something. So now we just need to find our y's. Okay, so now that we found two values for x, what we're going to do is, let's use red. We're going to take those two x values and plug them back in to these equations to get y. So if I do that, then I'm going to say, actually, I want to use this one right here. It doesn't matter what you use, just one requires a little bit less work. So if I use this equation right here and substitute in. So then I would say 2, and I'm plugging in 5 this time. 5 minus 3 equals y minus 5. Then 5 minus 3 is 2. 2 times 2 is 4. 4 equals y minus 5. Add 5 to both sides, and I get y equal to 9. So that is the point 5, comma, 9. And that is right up here, and I'm off a little bit, so I'm now going to fix that. So now my A is right here, and I'm going to erase this, and that is going to be my point 5, comma, 9. And I need to extend or expand my circle so that it is still centered there, but it's going to go to it's going to cross right there at. So my circle's not the right size. That's when I'm going to delete this circle. That was just an approximation. So now my point has moved to 5, 9. And then I'll do the other one. Let me use green. And now we're going to use 1 in this equation. So x is 1 would be 2 times 1 minus 3 equals y minus 5. And then 1 minus 3 is negative 2 times 2 is negative 4 equals y minus 5. Add 5 to both sides, and I get y equals 1. So that would be the point 1, comma, 1. And that is right here. So now I have a diameter that goes from 1, 1 up to 5, 9, going through the point 3, 5. These tangent lines need to move up, and this one needs to move down. Okay, and so now I'm going to put the circle in, but instead of using the compass, I'm just going to draw it like so. Okay, so there is my circle, centered at 3, 5, diameter of square root of 20 times 2, if you will, because the radius was the square root of 20. So this is 2 root 20, the blue line. Endpoint of 5, 9, and an endpoint of 1, 1. Okay, so we're making progress here. So we found the equation. They gave us the equation of the circle. We found the center using that equation. I'm just recapping here. And we were given the slopes of the tangent, so therefore we knew the slope of the diameter, or the 2 radii, is 2. And then we calculated our values all with this here, and we now found the endpoints of our diameter. So now that we have an endpoint and we have a slope, now I can find the equations of the 2 tangent lines. So in order to do that, I'm going to use point slope formula. I have a point, I have a slope on that red tangent line there. So the first one I will do, which is this one here, will be y minus y1, which is 9, equals our slope, which is negative 1/2, times x minus my x value of 5. So if I can just leave it like that. There is the equation of this tangent right here, if that were an arrow, okay? And then we're going to do it again for this one down here. So this equation is going to be y minus y1, which is 1, equals our slope of negative 1/2 times x minus my x1, okay? And we can just leave it in point slope form like so. So there are the 2 equations of the tangents that are tangent to this circle centered at 3, 5 with a radius of the square root of 20. Okay, page 3 brings us to exercise 1. Consider the circle with equations x minus 4 squared plus y minus 5 squared. So that is, whoops, that is centered at 4, 5. Radius equals the square root of 20. That is irrational, so we can't just draw it. Find the equations of 2 tangent lines to the circle that each have a slope of 2. So if they have a slope of 2, then the slope of the radii will be perpendicular, so they would have a slope of negative 1/2. Okay, so that's what we're going to do here. So the first thing we're going to do is plot the point. So 4, 5, let's use black. 4, 5 is over 4 up 5 right here. There's my center. 4 comma 5. And what else do we know? We know the slope of the perpendicular, or the radius, is -1/2. So if I go down 1 over 2, there's a point, down 1 over 2, down 1 over 2, or up 1 over 2, up 1 over 2, up 1 over 2, then that line is going to have my diameter and radius on it. So my diameter, radius are going to go through these points right here. Okay. All right. The next thing we're going to do is, we know the perpendiculars are a slope of 2 up 2 over 1, but we don't know their endpoints yet, so we need to find those. So if we know the slope equals -1/2, okay, and we have the 0.45 on it. Okay, so we're going to use the slope formula now and substitute m in. So we're going to say m, which is -1/2, equals y minus our y, which is 5, over x minus our x, which is 4. Okay, and then we're going to get y minus 5 by itself by multiplying x minus 4 to both sides. So I'm going to get -1/2 times x minus 4 equals y minus 5. So we're setting up the equation here. Here's our x minus 4. Here's our y minus 5 in the parentheses. And now we're going to square both sides. So if I just put a parentheses around here and square everything, -1/2 squared is a +1/4. And then the x minus 4 is going to get this 2 distributed to it. And that is going to equal y minus 5 squared. Okay. So then we transfer to our circle equation and we say x minus 4 squared plus y minus 5 squared equals 20. Okay, so now we have y minus 5 squared equals this. So we're going to substitute it in right here. So we're going to have x minus 4 squared plus, and instead of y minus 5 squared, we're going to replace that with 1/4 x minus 4 squared equals 20. So when I add these, this is 1 x minus 4 squared plus 1/4 x minus 4 squared. So think of this as 4 quarters. Anything divided, 4 divided by 4 is 1, and multiply it by, and that's not changing the value of by any means, but then we can see that 4/4 plus 1/4 is 5/4. X minus 4 quantity squared equals 20. Multiply both sides by the reciprocal to get rid of these, and I multiply this by 4/5. 5 would make the 20 a 4, and 4 times 4 is 16. So I get x minus 4 squared equals 16. So I want x, I'm trying to find x. So I'm going to take the square root of both sides, and that is going to give me x minus 4 equals plus or minus. So I'm going to split it up right now rather than writing this several times. So x minus 4 is going to equal +4. And let me move these over so I have more room. Okay, so x minus 4 equals 4, or x minus 4 equals -4. Add 4 to this side, I get x equals 8. Add 4 to this side, I get x equals 0. Okay, so we're almost there. We have 2 x's. So down here, I'm now going to use that x equals 8, and I'm going to substitute it into this equation right here. So I'm going to write -1/2 equals y minus 5 divided by, and x is 8, so it's going to be 8 minus 4. And that is going to be 1/2, negative 1/2 equals y minus 5 over 4. Multiply both sides by 4. And a negative 4 times a 4 times a negative 1/2 is negative 2. And that's going to cancel here, and we get y minus 5. And if I add 5 to both sides, I get y equals 3. So when x is 8, y is 3. Okay, so that means I go over to 8, up to 3, and this is where my circle ends, right there. Okay, so I'm going to erase this point, and I'm going to shorten my radius or diameter to there. And then we're going to do the other one. So I'll do that in blue. So now we're doing x equals 0. Negative 1/2 equals y minus 5 divided by 0 minus 4, which is negative 4. Multiply both sides by negative 4. And a negative times a negative is positive, and half of 4 is 2. These 4's cancel, and we get y minus 5 equals 2. Add 5 to the other side, and we get y equals 7, giving us the point 0, 7. So then I put a point right there, and then I'm going to shorten my diameter to there. So there is the diameter of our circle. So you would use your compass now. I'm not going to take the time to do that. I'm just going to use my circle formula, or my circle drawer here. And I'm going to draw my circle. Let's make it blue centered here, and a radius out to there, so that we're going through those 2 points. Okay, so there's our circle. Now I'm going to erase all my work down here. And now I need to find the equations of the tangent lines. So the tangent lines are going to be perpendicular to my diameter. So I'm going to start here, and it's a slope of 2. So I go up 2 over 1, up 2 over 1, like so. Okay, and then I can extend that down 2 over 1, down 2 over 1, like this. So there's the tangent. And if we do the same on the other side, just to save time, I'm going to do a copy. And there's the equation of our other tangent. So those are the equations that we're looking for, the equations of those 2 lines. So we use the point slope formula now. We know that the slope is 2. So we know m equals 2, and we know a point. So on this one, the point is 0, 7. And then we're going to do it again. M equals 2, and we have the point 8, 3. So point slope formula says y minus our y equals our slope, I almost wrote m, equals our slope 2 times x minus 0. Okay, and over here we're going to say y minus our y equals our slope times x minus our x. So there are the 2 equations we were looking for, right here and right here. And we're done. Okay, page 4 brings us to example 2. It says, refer to the diagram below. It says, let p be greater than 1. So all that means is the value of 1 on the x-axis is somewhere between p and here. This is the origin, okay? So let's label that. So this is the origin right here. Where's my pen? That right there is the point 0, 0. Okay? So 1 is somewhere before p. P is greater than 1. That's all that says. What is the equation of the tangent line to the circle x squared plus y squared equals 1? Well, that tells us right there that this value right here is 1, because the square root of 1 is 1. So the radius of this circle is 1. So here's 1. So obviously p has to be greater than 1. And then it says through the point P0. So this is the point over some value p comma 0 where p is greater than 1. We don't know what p is, but we know that the y value is 0 on the x-axis. Okay, and then it says point of tangency in the upper half plane. Well, it's in the first quadrant, and here's q. So let's label that some x comma y that we don't know. All right. As I'm going to work this, there's other things I know, so I'm going to label them. Let's use a really nice thin line, starting from the origin, going up to q. That is a distance of 1 because it's a radius. And we want to find the slope of it because what are we trying to do? We're trying to find the equation of the tangent line. So let me do that in blue. We're trying to find the equation of this line. Okay. So we need to find the slope of the radius first. So slope equals y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right. Well, if this is our y sub 2, so that's going to be y minus our y down here at the origin, which is 0, divided by x sub 1 minus, or x sub 2 minus x sub 1, which is x minus 0. So the slope of our radius is going to equal y over x. Okay. Now I need to find the slope of the tangent. Well, it's going to be the negative reciprocal, but let's find it in terms of x, y, and p naught, p comma 0. So I'll do that in blue. So the slope is going to again equal y2 minus y1 over x2 minus x1. And in order to find this slope, we had to go from y. So the change in y was a distance of y. Y down to 0 is y minus 0. Okay. Y minus 0. And then x minus p is our denominator. Okay. So the slope of that is y minus, or just simply y over x minus p. Okay, so keep in mind that this is the perpendicular to this. So if I flip it and change the signs, then it will be equal to this. So now I can say the y over x is going to equal the negative reciprocal of this. So I would, if I flip this over, then I'm going to multiply this by -1 and take the reciprocal. So that is going to be y is going to stay in the denominator now. And you don't want to switch the top and the bottom and make them both negative because the negative divided by a negative is positive and it's still going to be the same. So you only want to change the sign of the numerator. Well, in order to do that, we would get in the denominator, distributing this, we'd get a negative x plus p. So if I just write that rearranged, I can just say it's p minus x. Okay, hopefully you followed that. So now we have y over x equals p minus x over y. Okay. So then when we cross multiply, we're going to get y squared equals x times p minus x. Okay. And then when I subtract y over to the other side, we're going to get x times p minus x equals 0. Oh, not equals. I forgot my y. So if I subtract y squared over to the other side, it's going to become y squared. Oops. Let's think about this again. Okay. Let me just flip it over after I'm done. So I'm going to subtract y squared from both sides, leaving 0 here and getting x times p minus x. And I subtract y squared over to the other side, so now it's here. There, that's better. Okay. And then I can distribute here and get 0 equals, and then this would become a negative x squared, right? Actually, let me just leave it in the right order so I don't confuse you. X times p is xp minus x squared minus y squared. Okay, so now I can multiply everything by a -1, and I'm going to, or if you think about moving everything over to the other side, we're going to get y squared plus x squared minus xp equals 0. Okay? All right. So x squared plus y squared, and let me put those in the right order now. Let me just move these, rotate them around. Addition's commutative, I can do this. So y squared plus x squared is the same as x squared plus y squared. Well, x squared plus y squared equals 1 in this case. So we're going to get 1 minus xp equals 0. And so therefore add xp over to the other side, and then we would get xp equals 1. Solving for x by dividing by p on both sides, we then get x equals 1 over p. Okay, so now what do we do with that? Okay, so now we want to use the expression for x to find an expression for y. So let's use this equation here. So if I have x squared plus y squared equals 1, and I want y by itself, I get y squared equals 1 minus x squared. And then when I take the square root, I get y equals the square root of 1 minus x squared. Okay. Well, x is 1 over p, so that's going to get substituted in now. So we get the square root of 1 minus, and then 1 over p squared, think of it as this, squared, it's going to square the numerator, which is still going to be 1 squared over p squared. Okay? Hopefully that makes sense to you, and we'll continue. Let me just get rid of this now. Just wanted to show that. All right, so now we have an expression for y. Y is the square root of 1 minus 1 over p squared, which simplifies to, so how do we simplify that? Well, y would equal the square root of 1 minus the square root of 1 over p squared. So y is going to equal 1 minus 1 over p. No, it's not. Let me see. Okay. Disregard this step right here. I cannot break up a radical with a subtraction in between. I don't know what I was thinking. Okay, so we need to simplify this. So we're going to end up with, let's see, how do we simplify that? Okay, so now what we need to do is combine like terms under the radical. So I'm going to call this 1. Whoops. Hello. Call this 1, or I'm sorry. Hello, think. Okay, p squared. We want p squared in the denominator, right? In order to add fractions, we need the common denominator. So 1 would be p squared divided by p squared. So when we do that, we get y equals, and our numerator is going to be p squared minus 1, and it's going to be divided by p squared. Okay, so think of that as a square root of p squared minus 1 over the square root of p squared. So that is going to come out to be, the square root of p squared is just p, but it's 1 over, think of a 1 out here, so that can come out of the radical and just have 1 over p times the square root of our numerator, which is p squared minus 1. Okay, and then, so now we have, this is y, and this is x. So now we have the point 1 over p, comma, 1 over p times the square root of p squared minus 1. So that would be the point right here. So the slope of OQ in terms of P now would be the slope of OQ in terms of P. If this is my point, the slope is y2, which is this, over the slope of the x. So now we're saying, well, now that's y over x. So our slope now in terms of P would be y over x. Here's my y. So it's 1 over P square root of p squared minus 1 divided by x, which is 1 over p. Okay? And then when I multiply this, when you divide by a fraction, you multiply by its reciprocal, these would cancel. So the slope is the square root of p squared minus 1. Okay? And therefore the slope of QP, which is the perpendicular tangent, is going to be the negative reciprocal of this. So it's going to be negative 1 over the square root of p squared minus 1. Okay, and that simplifies to, if I multiply the top and bottom by the square root of p squared minus 1, I'm going to get the negative square root of p squared minus 1 over the radicand p squared minus 1. Okay, so what's the equation of line? What is the equation of the tangent? So now that we have a slope and we have a point, then in terms of x, y, and p, we're going to get y equals, and the slope is negative square root p squared minus 1 over p squared minus 1 times x minus p. And there's the equation of the line, because it's going to be y minus y1, which is right here, and then that gets moved over to the other side, divided by, or equals, the slope times x minus x1, and it comes out to be this here. Okay, here's page 5, and I got thinking more about this. So this problem down here, if this is a positive slope of, say it was 3, then this would be going down. If it's a mirror image across the x-axis, it'd just be the negative of that slope. It's not the negative reciprocal, which was what I was thinking, so that is right. Okay, so it doesn't matter if it's a 45-degree angle or not. It's just the negative of the slope being reflected across the x-axis in this case. So the next page, which we are on now, is what is the slope of q prime p? So the slope of q prime p, remember, let me just draw it in there. This would be a point straight down reflected across the x-axis right there. I thought that was black anyway. And then I would draw a red segment for my radius from here to here. And then a blue segment for my tangent at that point of tangent C. Okay, so if this slope here, which we found, what was the slope of QP? If we go back and look, the slope of QP is negative 1 over this, or in other words, negative square root of p squared minus 1 over p squared minus 1. Okay, so part C says, what is the slope of q prime p? It would be this negative. So I'm going to copy this over. Okay, like so, but I'm going to get rid of the negative sign. So it's going to be the p squared minus 1 square root divided by p squared minus 1. And that doesn't really look like a 2 now that I look at it again, but that's a 2. All right, so there it is. It's just the opposite of this slope here. And D says find the equation of the second tangent line to the circle P through P0. Or PO, I mean. You know, that's P0. Find the equation of the second tangent line to the circle through P0. Okay, so what that should be, this should be actually going over to here and like so, and let me move it up. Okay, so there's the tangent line. Would be more like that. There, that's a better depiction. Okay, so I want the equation of this one going through, and this was q prime. Find the equation of the second tangent line to the circle going through that point P comma 0. So what was the equation of the last one? So let's go take a look at that. It was right here. Okay, so the only thing that's going to change is this minus sign. So let's copy this equation over. And then I'm going to just write y equals, and this negative is going to go away. So this is the slope with the same point x minus p. Okay, and that is D. Number 3. Show that a circle with the equation x minus 2 squared plus y minus 3 squared equals 160 has two tangent lines with the equations y plus 15 equals negative 1/3 x minus 6 and y minus 9 equals 1/3 times x minus or plus 2. Okay, so now we're on to exercise 2 in the same page. And so I just brought down the diagram because it says use the same diagram from example 2 above, but label the point of tangency in the lower half plane as Q prime. Okay, so what they're saying is Q prime is going to be in the lower half plane. So I need to draw a tangent, or I'm sorry, a radius. Let me extend that radius from the center down to here. Okay, and then I'm going to draw a tangent to that, like so, and oops, okay, and let me just put it like that. So there we go. So we're going to name this Q prime, not Q sub 1, Q prime. All right, so use the same diagram, but label the point of tangency in the lower half plane as Q prime. What are the coordinates of Q prime? Well, if this was over 1 up 2, that would be the point 1 comma 2. And if we reflect it across the origin, then it would be left 1 down 2. So there'd be negative x, negative y. Just like if we went over here, it'd be 2, 0, and this would be negative 2, 0. So when you're reflecting across and 0, then there's no negative 0. It just, you take the negative x, negative y. So the coordinate of Q prime would be okay, so hang on. What are the lower half plane as Q prime? So there's two different ways we could look at this. This could be located directly across like so, or it could be a reflection across the x-axis and putting Q prime over here. And that's what I'm probably going to do. This is my, let me just delete all that. So what we're going to do is we're going to put a point reflected across the x-axis down here. So if this was over 1 up 2, this is over 1 down 2. So it's still going to be the same x. So where is our point from the last problem is right here. So this equation, or this point, is going to be over the same distance to the right, which is still going to be 1 over p, but it is going to be negative 1 over p times the square root of p squared minus 1. And let me just move this over here where it would be perpendicular to this radius at that point of tangency. So we're going to go to they weren't very specific as to where the lower plane was, but I guess this is what they mean. Okay, so like that, reflecting Q down to Q prime. So that point of tangency is 1 over p comma negative 1 over p square root p squared minus 1. Okay, What was the slope in the last problem? The slope was right here, which was square root of p squared minus 1. So it's going to be the negative. So I guess what they're going to say is, let's see, let's draw this a little bit better. See, I don't know, I'm just having a problem with this. If this was a 45-degree angle, in other words, if Q was halfway between the x-axis and the y-axis, and it was here, then I come straight down here, then I would agree that they were perpendicular. But the slope of O Q prime is going to be, this would have to be, OQ prime. The slope of OQ prime would be negative square root of p squared minus 1. Since this slope was p squared minus 1 square root, this would be the negative. So it's going to be a reflection. So their diagram really isn't drawn well. It should have been a 45-45. Okay, but we'll go with that. So since the slope is positive, this one would just be the negative of the slope we calculated here in exercise or example 1. Or what was that? Example 2. Okay, page 5 continued to number 3. It says, show that a circle with equation x minus 2 squared but plus y plus 3 squared equals 160. Show that that equation has two tangent lines with equations y plus 15 equals 1/3 times the quantity x minus 6 and y minus 9 equals 1/3 times the quantity x plus 2. So before I continue, notice that the tangent has a slope of 1/3. So therefore, the slope of the radius or diameter would have a slope of, the slope would be -3. Okay, for starters, that would be the slope of our radius. So if we had a circle, I'm just going to do a quick sketch. If we had this circle and then we had a tangent line too, or not a tangent line, but a radius starting at the center with a slope of -3, that'd be down 3/1, down 3/1, down 3/1, and be down here like this. And it would continue in the other direction. So I'm just doing a quick sketch here just to get an idea of what it might look like, something like that. So therefore, we're looking for the tangent lines, equations of the tangent line, which, oops, I forgot to do my straight line thingy. Let's do this and blue and thinner. So I would have one tangent line here. That would be moved down a little till it's just touching. And then paste another one in here, and that would end up coming over here and touching at that point of tangency. So here's a quick sketch of what we're doing. The equation of the blue lines, our tangents, are right here. So I'm going to go back now. So now we know the slope of the radius is -1 or -3. The slope of these tangents is +1/3 as shown right there. Okay, so where are these points coming from now? Let me go back 2 pages and point something out to you. When you use point slope formula like this, the y value that is here, you take the opposite, and that is your y value in your endpoint. The x value's opposite is the x value in your endpoint. So if I move back to this problem that we're working on, and I look at my y value of 15, y plus 15, and x minus 6, then I have the point, or +6, not negative, +6, comma, -15. So there is a point on that line. That's the end point. And that would be over 6 down 15. That would be this one here. And then the other one has a y minus 9 and an x plus 2. So my slope again is going to be -3. And I'm talking about the red diameter. And the end point is going to be the opposite of the x, the opposite of the y. So there is this point right here. That is the point -2. So if this were the center to -3, then we go over -2 up 9, or the point -2,9 is right there, and the 0.6 -15 is right here. Okay, so there's our slope of our diameter, and there's the endpoints of our diameter. So we're trying to show that a circle with this equation has two tangent lines with these equations. So we're going to take this formula now and set it equal to 160. So we want to prove that x minus 2 squared plus y plus 3 squared equals 160 for both of these endpoints. So I'm going to write it twice. Okay, so there's the two equations, and this one I'm going to use these values. Okay, so we have x minus 2. Well, what's my x? Well, it's 6. So I'm going to substitute now. So it's going to be this 6 right here, this x minus 2 squared plus my y, which is -15, plus 3, quantity squared, has to equal 160 if this is true. Well, 6 minus 2 is 4, and -15 plus 3 is -12. 4 squared is 16. A negative squared is always positive. 12 squared is 144. And we have just shown that 144 plus 16 is 160. Okay, so this point satisfies this equation. So now we're going to check it with our x and y that we have in this point. So it's going to be our x, which is here, -2 minus 2 squared. And let me change so that just the number is green. So there's our x minus 2 squared plus our y, which is 9 plus 3, quantity squared, has to equal 160 to satisfy this point being on that circle. So -2 minus 2 is -4, and we are going to square that, plus 9 plus 3, which is 12, and that is going to equal 160. Well, -4 squared is positive 16, and 12 squared is 144. And as you can see, we're getting the same values here. So 160 again will equal 160, and that checks. So that is how we showed that the tangent lines with these equations, or these lines with these equations, are tangents to this circle. Okay, so now it says, could a circle given by this equation have tangent lines given by these equations, and explain how you know? So again, just to really quickly explain this, I'm just going to draw a circle, and we have two tangent lines. So first of all, we know the slope of the tangent lines is 4/3. That's 1 1/3. So if I drew an approximation, all I'm concerned about is that we have a positive slope. So it's a little more than a slope of 1. So what does 1 look like? Slope of 1 looks kind of like that. So just a little bit more. How about that? Okay, 1 1/3. And then we're going to have another one on the other side, like so. That means that if we have a center that is right here, that we're going to have a diameter that's perpendicular to these two tangents. So it's going to have a slope of -3/4. So when I do that, it will look like this. Okay, so that's a negative slope. So that's approximately like what we're looking for. So we're looking to see if these points will end up right here with that slope, and we want to see if it's true. So the first thing I'm going to do is say, well, okay, the slope is of these lines is 4/3. Okay. Or the slope of the diameter or radius is -3/4. That's what I wanted to put there. But we have the point. Let's do this with color. How about blue? And the x minus 1, so that would be 1. And -4, which would be a 4. Because 4 minus 4 is 0, 1 minus 1 is 0. We want to find what makes each side equal to 0. So there's the point 1, 4. And then if I come over here, I have an x comma y with the same slope, -3/4, and we're talking about the slope of the diameter, not the slope of the tangents. And x minus 8, so x is 8, y minus 5, 5 minus 5 is 0, so there are our 2 points. We then write the equation of the circle, x minus 5 squared plus y minus 1 squared equals 25. And we're going to write it again. X minus 5 squared plus y minus 1 squared equals 25. Okay, so we're going to substitute in now. So we're going to get x minus 5 squared plus y, which is 4 in this problem, 4 in this equation, minus 1 squared has to equal 25. Well, 1 minus 5 is -4 squared plus 4 minus 1, which is 3 squared has to equal 25. Well, -4 squared is 16, 3 squared is 9, and it has to equal 25. So 16 plus 9 is 25. So that point truly satisfies the equation. So we're going to do it again over here. We're going to substitute in our x with this x and this y. And x is 8 minus 5 squared plus y, which is 5, forgot to make it purple. Okay, 5, this y, minus 1 squared has to equal 25. 8 minus 5 is 3. 5 minus 1 is 4. Okay, and 3 squared is 9 plus 4 squared, which is 16, equals 25, and 25 equals 25. So that's how you show if given tangent lines are actually points on that circle with a slope that is the negative reciprocal to the diameter. Okay, I'm going to go back to this last question now because just checking these does not prove. There's one thing that we also need to check. We need to check the slopes to see if those are true. So in this problem, we need to find the slope of these equations. So I'll do it right here. So if I take the slope on number 3, then that has to equal -15. So you take these 2 points, the slope has to equal -15 minus 9, y2 minus y1 over x2, well, they're calling this one x2 and this one x1, minus a -2, which is plus 2. -15 minus 9 is -24, and 6 plus 2 is 8, and that comes out to be -3. So this slope is equal to that slope. So that case, it can happen. Checking down here, yes, the 2 equations were equal, but I haven't checked the slope yet. So now when I check the slope between these 2 points right here, what is the slope of these endpoints, which should be these 2 endpoints? Is the slope of this going to be the negative? That should be, oh, I see what's going on. See that right there? And see this right there? That right there tells me that they're using different slopes. So these 2 lines are not parallel. So right there, if I now just use that as an example or a reason, then we have just shown that this blue line has a slope of 4/3 and this blue line has a slope of 3/4. So they have different slopes. So they can't both be tangents to the endpoint of the diameter. So if this has only a slope of 3/4, then it is going to do something like this. Okay. Okay, so obviously these 2 are not going to be at the right location. So we had to go over here to get a perpendicular. But if I continue and didn't notice these 4/3 and 3/4 like I just noticed just now, you can't overlook that. That would be the answer right there. Oh, these 2 slopes are not equal. These 2 lines can't be parallel. So, but if I check the slope of these 2 endpoints, then I would say y2 minus, I'm sorry, y, not x. y2, 5 minus 4, y2 minus y1 over 8 minus 1, which is x2 minus x1. 5 minus 4 is 1. 8 minus 1 is 7. Houston, we have a problem. We would need a line with a slope of 1/7, or that would be a slope of 1/7 going from here to here. So we would need a slope of 7 here and here to make these two tangent lines. So these are not endpoints of the diameter. Okay, page 6 brings us to the end of lesson 19. Review the lesson summary and relevant vocabulary and go do your problem set.